Hi, my name is NURAMIYRA binti JULLE. I will be presenting part 1, which is construct appropriate graphs or charts to compare the relative frequency and cumulative relative frequency of each dataset. The table shows 5 classes of domestic airlines. To construct the graph, we must find the relative frequency by dividing the frequency of each class over the total of the frequency. The sum of the relative frequency must be equal to 1. After calculating the relative frequency, we will be finding the cumulative relative frequency. In order to get the cumulative relative frequency, we have to add the relative frequency of the first and the second class. Once we get the first cumulative relative frequency, the process will be continued until the final class and the total of the cumulative relative frequency is equal to 1. After collecting and calculating the data, we transform the data into a graph. The histogram is showing the relative frequency of the domestic airline, while the ogive is showing the cumulative relative frequency of the domestic airline. The shape of the distribution of the histogram graph of the relative frequency is positively skewed, and the ogive of the cumulative relative frequency is increasing. The next table is the data of international airline. The process of collecting and calculating the data is the same as the domestic airline. The total of the relative frequency and cumulative relative frequency must be equal to 1. Then we also transform the data into histogram and ogive. The histogram graph is showing the relative frequency and the ogive is showing the cumulative relative frequency of the international airlines. The shape of the distribution of the histogram graph is positively skewed and the ogive is also increasing.
In part 2 of our analysis, we will be calculating and comparing measures of central location in each dataset. Let's start with the mean. The mean is calculated by summing up all the data points in a dataset and dividing the result by the total number of data points. Based on our calculations, the mean for the airline domestic dataset is 642,696.542. And the mean for the airline international dataset is 742,362.375. This means that the airline international dataset has a slightly higher mean than the airline domestic dataset, suggesting that it may have higher values overall. Now let's move on to the median. The median is the middle value of dataset when it is ordered from smallest to largest. Based on our calculations, the median for the airline domestic dataset is 144,253. And the median for the airline international dataset is 143,671.5. This means that the airline domestic dataset has a higher median than the airline international dataset, suggesting that it may have higher values overall. However, it is important to note that the median only provides information about the central tendency of the dataset and does not give any information about the spread or variability of the data. Moving on to the mode. The mode is a statistical measure of central tendency that represents the value or values in a data set that occur most frequently. It is the value that has the highest frequency or occurrence in a given set of data. In our analysis, we found that neither dataset had a mode since each value appeared only once. This means that there is no value that occurs more frequently than others in the given dataset.
Hello, my name is NAJLAH binti ISMAIL. My metric number is BT12703, and I'm going to present my part, which is part 3. Calculate percentiles and construct box plot in each dataset. To get the percentiles, we must use formula LP equal n plus 1 times P divided by 100. And for 25 percentiles, 24 plus 1 times 25 divided by 100 is equal 6.25. To get 50 percentiles, we must use the same formula as the 25 percentiles, and we can get 12.5%. And for 75 percentiles, we can get 18.75%. So first is domestic percentiles. First is 25 percentiles, we get 141,202%. And for the 5th percentiles, we get 217,716. And for the 75 percentiles, we get 6,768,74.5. The next is international percentiles. At 25 percentiles, we get 93787, and 5th percentiles we get 137048.5, and the last is 75 percentiles, we get 165,069.5. Okay, so next is outlier domestic. To find the outlier, we must use formula Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times IQR. And from that, we can get the outlier domestic, which is any value smaller than negative 662,306.75 or larger than 148,0383.25 is considered an outlier domestic. So now is outlier for international. Any value smaller than negative 13136.75 or larger than 581,45.75 is considered an outlier international. So this one is box plot for domestic, and this one is box plot for international. That's all.
Assalamualaikum and hi everyone. My name is WENDA BINTI SHARIFF and my matrix number is BT12703. So today I will be presenting the part 4, calculate and compare measures of dispersion in each data set. Dispersion have 4 components. The first one is range. The second one, mean absolute deviation. The third one, standard deviation and variance. And the last one is coefficients of variation. The formula of range is maximum value minus by minimum value. For domestic flight, the maximum value is 4,269,181 minus by the minimum value 37,312, which will be 4,231,869. For international flight, the maximum value is 8,808,742 minus by 52,937, which will be 8,755,805. So from the calculation, we could see that the international flight is higher than the domestic flight in terms of range. And the next part is mean absolute deviation. To find mean absolute deviation, we have to find the mean. To find the mean, we have to sum up all the value in the sample and divide it by 24, which is the number of airline. And the answer is 642,696.54. So for mean absolute deviation, the formula is the total of the value of each observation minus by the arithmetic mean of the values divided by the number of observation in the sample. So for domestic flight, the answer will be 626,552.79. So the mean for international flight will be 740,362.38. By using the same formula, the mean absolute deviation for international flight is 1,205,876.44. We can conclude that the mean absolute deviation for international flight is higher than the domestic flight. So next is standard deviation and variance. So the formula of standard deviation is the total number of the value of each observation minus by the arithmetic mean of the value, power by 2, and then divided by n minus 1. So the standard deviation for domestic flight is 9.83 times 10 power by 12, while for the international flight is 3.64 times 10 power by 13. So next is variance. So the formula of variance is the square root of standard deviation. For the domestic flight, the answer will be 3,135,283.08. For the international flight, the variance is 6,033,241.25. From the calculation, we could see that the variance of international flight is higher than the domestic flight. So next is coefficient of variation. The formula of coefficient of variation is the variance divided by the mean. For domestic flight, the coefficient of variation is 4.88. For the international flight, the coefficient of variation is 8.15. So we can conclude that the coefficient of variation of international flight is higher than the domestic flight.
Hi, my name is Esther and I'm going to present part 5, which is calculate and interpret measure of association. So, from the data, we know that domestic is X and the international as Y. So first step that we should do is we have to find the X bar and the Y bar. To find the X bar, we have to sum all the domestic and then we have to divide it with 24 and also with the Y bar, and we get X bar equal with 64296.54 and then the Y bar equal with 740,362.38. For the measure of association, we're gonna use covariance and correlation coefficients. For the covariance, the formula is total x variables minus with x bar. We multiply with y variables minus y bar, and we divide it with n minus 1. So the number we get is 362433400 We divided with 24 minus 1, and we got the answer 11410, And for the correlation coefficient, the formula is SXY all covariance. We divided with SXSY. So we get the number is 1141014785000. We divided with the standard deviation that has been present from the previous presenter, which is 9.83 multiplied with 10 power of 12, and we multiply with 3.64, we multiply with 10 power of 13, and we get the last answer, which is 3.188866737. We multiply with 10 the power of negative 15. That's all for us. Thank you.